Okay, so today my group going to present a data structure project. So my group members are Nithiya, myself Pava, and Deva. So our lecture name is Point Hamida binti Osman. So the first situation will be explained by Deva.
Okay, now I'm going to talk about the situation one. So Microsoft image viewer is used to view the image. So the button previous and next image are linked, hence can be accessed by the next and previous button. So let's see the answer. Next slide. Okay, this is the answer for the situation one. Based on the situation one, doubly linked list is a short of linked list that carries a pointer to both the previous and next node in the sequence. So there are next node in the sequence. There are three fields in each node, which is two link field and one data field. Not in a doubly linked list thus as three parts, which is node data, a pointer to the next node in sequence, which is the next pointer, and then a pointer to the prior node, which is previous node pointer. So we use the head and null, and also the brief is the previous node address, and the data for the stored value, and the next is for next node address. Where the example for the doubly linked list is the we use the 10 7 and then 3 and the last is the 6. So according to the illustration previous refer, so to the previous node's data address, data reference refers to the data value, and next refer to the next node's address. In the given example, the first and last connected elements in the doubly linked list are named. So each link has a data field as well as a two link field labeled next and previous. So each link is linked to the next link by the link after it. So the final list will have a null link referring to the end for the list. So next question, Power will present.
Okay, for situation 2, market data are the live prices of different stocks at a given moment. So this market data system is used to analyze undervalued or overvalued stocks for buying or selling decision. So we need to store only recent market data for that purpose. As soon as we receive an update and old market data should be discarded even if it's not yet processed. Okay, so as we know, data structure is a way of organizing data and retrieving it eventually. So to assess this data structure, various operations are defined. So stack is LIFO, last in first out data structure. So the element insert last in the is the figure one to get out. Okay, so push and pop are operations defined on stack. Okay, so now we will understand this operation to this situation. Okay, we choose the stack operation based on situation 2. So a stack is a data structure that is made up of homogeneous, which is elements of the same kind, items that are added to the top of the stack and removed from the top. So we choose the stack operation because undervalued or overvalued are the total opposites of overflow and underflow in both. So overflow occurs when we attempt to insert data into a full stack, while underflow occurs when we attempt to remove data from an empty stack. So as we can see, we used push and pop. So push and pop are operations defined on the stack. So push is it will pushes element of the stack, while pop is it will remove the element from the stack. Okay. So according to the example, if stack there are five terms, which is underflow, overflow, top, pop, and push. So the process of deleting data is known as pop, and the process of inserting data is known as push. So first, it has an empty stack. As we can see here, this is an empty stack. Okay. So by inserting data, we know it is push. So plate one is insert in to the empty stack. Empty stack. So then we will insert one more plate into the push, which is plate 2, and then we will add another one, plate 3. So we can try to push plate 4 because the stack is full. We cannot push plate 4 because the stack is already full. So it will cause overflow. So following that, we will pop out plate 3, plate 2, and plate 1. So once we pop out everything, it will all the data have been popped. So this is known as underflow. So and it occurs when we try to remove data from an empty stack. Next situation will be explained by Deva.
Okay, the situation three is an operating system may use this type of data structure for directories, files, and folders in its file management system. So let's see the answer. Okay, we choose the type of descendant data structure based on the situation 3. For three structured directories are the most frequent thing. So the directory is generally stored in the form of the three. So it is a root directory which easy descendant in the system as their own path. So within a three structure directory, grandparents, parents, and child may be included root. So this is the our binary search tree. So the Alexander is a root, the Abner and Alex is the folder. So the file is in the file have Adam, Agnes, Ellen, and Alice. So a directory is a type of container that hold folder and files. So it's uses for hierarchical structure to organize files and directories. So the customer one is the Alexander, which is the root. So is the root or parents node is the directory tree structure because it only contains a root Alexander, which is the customer one. So as their own directory can and cannot access the directory of another user. So only the root directory is accessible to Alexander. So they cannot, however, write or to modify the root directory. The system administrator who has complete access to the root directory is given this privilege. So Hebner and Alex are the child node for Alexander, and then the Adam and the Agnes have Hebner as their parents node. Will Alex and Alex have Alex as their parents node. So this is the our binary search tree for the situation tree. Next, next I pass
Okay,
to
next.
Nitya.
Okay, thank you, Deva. Next is situation 4. The library has a database to store all the information about books status. Then it will start recording its status such as book availability, the book location, and etc. Okay, we have choose the linear search data structure based on situation 4. Linear search is a sequential searching algorithm in which we start at one end of the list and check each element until the desired element is found. It is the most basic search algorithm. Okay, this is the illustration. Based on the illustration, we choose books such as Harry Potter, Shadow, Secret, and Winnie's book. So the book mentioned the question was desire, and this is the linear structure we must find. To begin, check the element individually to ensure that it meets its requirement. The first step is the Harry Potter book is not present in the desired book because it does not meet the requirements. The second book is the Shadow. It also does not find the requirement because the second book is Shadow. It not found the desired book because the process will continue because the requirement was has not been met. The third one is secret book. It also not found in the desired book. The fourth book is the Venice is also not found in the desired book. The fifth desired book is found. So the requirement process meets the requirement process is meets.
So
Thank
that's all.
you.
Thank you.